Welcome to the Prepped and Polished podcast, the podcast that empowers you to take control of your education, featuring weekly interviews with influencers in the world of education, as well as tutoring tips, lessons, and updates.
Hi everyone, this is Terri Karol of Prepped and Polished, a tutoring and test prep firm that provides in-person and online tutoring for the SAT, ACT, grad school tests, private school tests, and academic subjects such as math, science, English, languages, and study skills coaching. For more information, please check out preppedandpolished.com. Get to know the Prepped and Polished community. You can find us on Facebook at Prepped and Polished, as well as on Twitter and Instagram. Just search for Prepped and Polished. Remember, if you have any questions or comments about the episode, feel free to email us at any time, radio@preppedandpolished.com. We love hearing from you, so let's get right to it. Well, today our focus is on the ACT science test, preparing for that science test. And I always try to reassure students. I tell them about someone who knows how to prepare for test day, and they can use that person as a role model to kind of inspire them. You know, even if you're not a football fan, you most likely know about Malcolm Butler's interception that made Super Bowl history and turned him into an overnight sensation. And this did not happen by chance. Butler, just in case you don't know, a rookie cornerback for the New England Patriots, had anticipated, studied, and prepared for that exact pass for weeks prior to the Patriots' victory. So Butler was ready on Super Bowl Sunday. He anticipated exactly what play was coming and made an incredible interception to assure the Patriots' victory. And I tell students, just like Butler, you can anticipate what is covered on the ACT science test, prepare for it, and excel. Students often find the ACT science test daunting. They're not sure what to expect or how to prepare for it, and they know that it comes at the end of the ACT exam when they're getting tired, so I like to share some reassuring facts with them. I tell them, keep in mind that the ACT is really an open book reading test based on science with some added charts, graphs, and tables. So you'll be prepared if you take a strategic approach to finding answers rather than trying to study all the science that you've learned. There's nothing that you need to memorize from biology, chemistry, geology, physics, or any other science course for the ACT science section. You certainly don't need advanced knowledge of any topic. But you will need to draw upon your high school experience. It's helpful to know what is the scientific method, what's a control, a catalyst, a hypothesis. Can you predict and draw conclusions? I tell them that all the info that you need is presented in the passages and provided in the diagrams. No calculators allowed, so there can't be too many calculations. The most important ACT science strategy is don't be intimidated. And the way to alleviate that is to know that strategies are the key. Practicing sample ACT science passages ahead of time is the best strategy for doing well on the science test. The second most important ACT science strategy, work quickly. I'll fill you in a little more about pacing later, but in general, students need to read the paragraphs quickly to get the idea of what the experiment's generally about, glance at the graphs, and then go to the question, because each question tells you which table or graph to examine to find the correct answer. The most common ACT science question asks you to find a value or fact from the tables or graphs, and usually the questions tell you which table or graph to look back at, like it would say, according to Figure 1. The second most common type of ACT science question asks you to look at a chart or graph and decide what happens to one thing as another changes. And the third most common type of ACT science question asks you to use the graph or table to determine the value for a data point that's not shown but is above, below, or between the points that are shown. Students need to base their answers solely on the information given. So for example, say a question asks about the height of volcanoes. A student shouldn't pick an answer choice about the density of lava, especially if the passage doesn't mention lava. It's very helpful to formulate answers before looking at the choices. This helps to avoid tempting but wrong choices, and students shouldn't be thrown by formal scientific names. Further reading usually defines terms like Laminaria farlowi is really just plain old kelp. So now I want to get to a few specifics about the format and pacing. It's very comforting for students to know that the format never varies. It's very predictable. There's 7 passages of scientific information, each of which is followed by 5 to 7 multiple choice questions. The hard part is that there's only 35 minutes to answer 40 questions, which translates to about 5 minutes per passage and accompanying questions, a little less than a minute per question. The scientific information is conveyed in 3 different formats. First up, there's 3 data representations. These are chart-based. They seem to be the easiest for students, and they test your ability to understand and analyze data presented in one or more charts, graphs, or tables. An example of a data representation might be a short passage and accompanying figures examining the altitudes at which certain wavelengths of solar radiation are absorbed. So I tell students that it really helps to mark up the main points of the passage and circle the key figures. It sounds silly, but I say don't underestimate the power of the pencil. And again, don't let all the words in the passage intimidate you. Typical questions direct you to find a value or fact from a table or graph, often beginning according to figure or table 1, so the student only needs to focus on figure 1 or table 1 to find the answer. I often suggest a simple 4-step drill to simplify the process. First, just read and summarize. What does the graph show? Identify the variables. Get familiar with what is an independent variable, the one being manipulated, often represented along the horizontal axis. What's a dependent variable? Check out units that appear as labels on the axes, and most importantly, notice trends. How are quantities related? As x increases, does y decrease or stay the same? Are the points scattered? Next up are 2 to 3 research summaries or experiments. Students have to consider the experimental design and interpret results in tables and graphs. On the actual ACT, an example might be something like, solids, liquids, and gases usually expand when heated. 3 experiments were conducted by scientists to study the expansion of different substances, and there would be 3 experiments with diagrams, figures, and 6 questions. Again, if a student reads and summarizes each experiment, what's the hypothesis, what is the experiment trying to measure, what links and distinguishes each experiment, that really helps. Take special note of the apparatus used, the setup of the experiment, variables, also the results and trends, and what's the conclusions. Last up is conflicting viewpoints. These seem to be the most difficult for students. The questions test understanding, analysis, and comparison of competing viewpoints and hypotheses. And I tell students you have to be an active reader. Make notes in the margins summarizing each viewpoint, underline supporting data for each theory. Interpret and analyze points of agreement and disagreement. That will really answer the questions of the passage and keep the 2 viewpoints straight. If the question asks according to scientist 1, only look at scientist 1's argument. Here's a good example of a conflicting viewpoint. Which student, if either student 1 or 2, would predict that smoke from burning wood will rise up the chimney from a fireplace on a day when the air at the top of the chimney is not moving? And the student would really have to understand that, unlike student 2, student 1 maintains that smoke rises because of buoyant force on hot gases inside the chimney. So buoyant force will be present whether or not wind blows across the chimney. Well, I tell my students that, as the saying goes, the butler did it. He worked hard, he was prepared, he saw the end game, and he made it happen. And they can prepare just like Malcolm Butler and perform well on the ACT science test. My best advice? Practice under actual test conditions using the strategies that I told you about today, 35 minutes for a whole test or 5 minutes for one passage. And remember, there is no penalty for guessing. That's a real benefit. Well, this wraps up our show, episode 53, Prepped Like Malcolm Butler, Excel on ACT Science. Thank you for joining us on the Prepped and Polished podcast. Now go out there and take control of your education.
You've been listening to the Prepped and Polished podcast. For more information, check out preppedandpolished.com. Also, you can follow us on Facebook and Twitter. Thanks for listening. Class dismissed.